I am here with the famous
Ah,
number one best-selling Amazon author, Phil Beisel.
yeah.
Now, is this your first time to have a an Amazon best-selling book?
Yeah. Did you note what I didn't say? I've never had any books on Amazon at all.
Yeah, right.
Um,
Well, so just for those out there who have not, like you, have not had a book on Amazon or written a book, what was the experience like? I mean, I know it was only one chapter, but there was 4,000 words. My wife teaches English at the she's
yeah.
a professor, and she has students that come into her university who probably have never put a 500 word
Mhm. It
essay together. So anyway, what was the experience like actually writing, being part of the book?
was great, actually. I mean, people that have watched me in the past know that on X, I mean, I write articles. I write a lot of long form posts on X, and I've done that series on FSD. I think I have 24 articles over 2 years up there, and most of them are in the range of 2,000 to 3,000 words. So, and
Right.
I think the chapter is longer than that. I think
Yeah, I think it's
it's
around four or five. Yeah.
yeah. It wasn't hard. I think what I struggled with mostly was I think it could have been 20,000 words. There's a lot to there's a lot to say. So my chapter is data, the lifeblood of AI. I decided to pick something I knew about. We'll talk about that in a minute. But um, and then I was like, well, I don't really. It should be more. It shouldn't be super technical, right? I don't want it to be super technical, but there's so much technical material that's not there.
Right.
Like it literally avoids the deep technical and it talks more topically. Um,
Well, our goal, so everybody knows, and we didn't always hit this goal, but our goal, I even told Grok, I want this to be readable
mhm.
by somebody who's graduated from high school who is very interested in AI. So it could be a graduate from high school who
Yeah,
also went on to college and went to, got a master's. But if they only graduated from high school, but they were really interested in AI, that they would be able to read this and understand it. That was the
yeah,
goal.
yeah. No, I think we hit that mark. Um, what I like about this is I like the variety of authors. I like I've been reading it myself. Yeah, it's well, I mean, I read some before.
Yeah.
I read Cern's chapter before, and one or two of Brian's. I can't remember, but um, I was kind of consumed with getting mine to be as good as it could be in this crowd. I don't want to look like an idiot.
Well, okay. So
So
so Tesla is famously, in addition to so many things that they are superlative about, one of the superlatives that's often used is they have more data than anybody, and that
yeah,
this is a
right.
huge moat. And the data that they have, most people are just thinking about the robotaxi data, but they have mass amounts of data about how the car works. They have mass amounts of data about what happens in an automobile accident that nobody else has.
Right.
They have data on top of data with regard to just the vehicle. And then you go beyond the vehicle, you go into the data about the manufacturing facility,
Yeah, that too.
and you have that data. So,
Yeah.
I mean, and we could go on, but data is what it was about 20 years ago. They started saying that data was the new oil. Was it longer than that?
You know, it, I don't know. It's really a fascinating topic because there's so many things have had to right size them in technology to make this revolution in data happen. Actually, we should jump into the presentation, I think.
You can go for it. You can go
Yeah.
for it.
So let's do that share thing that we do.
I did. I think it's done.
I'm ready to go. Here we go.
Right.
So let me put this into you know, presentation mode.
Absolutely.
Yeah. So for those watching, I wrote this chapter, Data, the Lifeblood of AI, and I put on the screen all the sections in the chapter.
Mhm.
Um, there's a lot there. I mean, it really goes around, it moves around a lot of different area. So I think, it's kind of worthwhile read. But here's the tee up on this. I really wanted to say that, if you, beyond the philosophy, the philosophical, the other aspects of AI that are covered in the book, the future, what the future state of society looks like, all these types of topics. On a sort of more technical level, we're really just dealing with data algorithms and compute, and what's fascinating and reason why I wanted to jump into this is that all of these things have come to bear together to kind of enable. It's sort of like, it's the fascinating thing about technology is that you really have to create something. Enough stuff has to be foundational, available, that you can enable something. And this something was, how would you train these dense neural networks with data? And so you needed a couple things. People understood the concept of the neural net fairly well prior to massive compute and what we see today. But there really wasn't, years ago, enough compute to build these dense models and this is what's on screen, sort of the essence of a neural network, in a sense. All these hidden layers and these nodes interconnected through all those lines are representing effectively the parameters of the network, the weights. And we couldn't do this until we had compute. But the second we had enough compute, we wanted more data.
Right.
Because the more data we had, the more accurate the neural net would be predictively. So it's a fascinating, kind of flywheel type of thing that has had to occur. Like, I think there are certain things that happened within within the algorithm itself that allowed it to, build the LLM, et cetera. But the concept of the neural net was understood many years ago. I don't know exactly. I didn't do a history. I didn't buff up on the history of it, but it's been around forever. And there's been sample ones built, and eventually the ImageNet came online and for predicting image recognition. And here we are. If you look at the compute required to do something the order of Tesla's full self-driving, it's hundreds of at least 100,000 GPUs running full out for 2+ months to set the values within this very thing, the neural network.
Yeah, and then I'm sorry. And then one of the things that we did in the book was, I like the way you said it. As the compute went up, you had all this data, and you say, I need more compute. Then as you got more compute, now you said, oh, I need more data.
Yeah,
But it goes beyond that. It's
yeah,
also, now I need more energy. Now I need more raw materials. And then once I'm doing this, what good is it if there's not inference and applications? And so we tried to cover that whole thing with 8 different papers
right,
that covered what we call the entire stack. And the data was that you're part of the stack.
right, exactly. So yeah, I do want to focus on the data aspect, but I would say that, large data sets give rise to the idea that we would need different compute mechanisms, and we've come to there's certain operations that are involved in the training, notably matrix multiplications, that are so common that they can, and the problem was inherently something that you could break down in parallel bits. So this thing called the GPU was a natural fit because it was already doing that
Parallel. Yeah.
type of thing on screen, with our 2 to 4K computer screens. These GPUs were essentially doing these matrix math operations at blindingly fast speeds to do imaging on the screen, among other operations. And then, the neural net needed that. And the second it got enough of it, then everybody wanted to pour more data into it. So that's kind of where we're at. You got to look at all three. I thought what I would do is just talk about a couple of the sections,
Sure.
not with a great, rigidity, but just running around.
No, we want to give the audience enough of a tease to buy the book.
Yeah.
Anyway, and also
Well,
I just want to say, as you were describing your chapter and describing what you put into it, any somebody thinking about they don't read books, okay, but maybe they do read articles. They don't read books, but they listen to books, or
mhm.
they read they're not really a big reader, but they're really interested in AI. The book is designed in such a way, every single chapter in this book is worth 298. If you only are interested in data, believe me, you're going to get $2.98 worth of information out of the data and knowledge and insight out of the data chapter.
Yeah, I think that's true.
Yeah, go ahead. I'm
That's
sorry.
true. No, it's fine. So I wrote a section called The Beginning, Big Data, and I just wanted to talk about my journey
Mhm.
and how I arrived. Some folks know that I founded the technical team at Rivian
Right.
back in 2017 here in well, it was in San Jose at the time, but eventually, it's in Palo Alto. Um, and now it's a huge team, huge number of engineers involved. That team was responsible for the development of the network architecture of the vehicle, essentially the software-defined architecture, responsible for the software on the application displays, responsible for the mobile application, and then this funny thing called the cloud or big data. And so, what happened to us along the way is when we started, a lot of effort was focused on the vehicle itself, of course, right? We're building a vehicle platform, we're putting vehicles on that platform. Um, but we recognize, obviously, that the vehicle generates an enormous amount of data. As a, you know, sort of a common term to use is Internet of Things device, an IoT device.
Right.
It's a sort of any connected device to the network that can participate in receiving commands or or providing data. Providing data to some type of thing like the cloud or what have you. And so the Rivian vehicle, like the Tesla vehicle, is a huge provider of data. Huge. It's probably the largest kind of IoT device in existence, maybe beyond special machinery. Just the amount of data from the sensors internally is quite enormous. I have a beyond the book. I have a chap an article on X about vehicle data specifically. If people want a deep dive on it, the picture in the center is me in one of our prototype vehicles
Mhm.
about a year before launch. It's it's camo, but not really. It wasn't really for that purpose. The car was debuted at the time. It's just a fun thing to do
Sure.
to wrap these cars with all these different. So this is an R1T vehicle, very similar to the production vehicle that followed roughly a year later, and um, and that car, as I remember this day very very well. That my entire drive recorded every aspect of data, collected every aspect of the data from the vehicle, not just, when a lot of people, when they think of data on the vehicle, they think a lot about FSD and they think about the cameras as sensors. Uh, that's, of course, a huge, dense amount of data, and in Tesla's case, it's 8 cameras, 5 megapixel uh, density, 36 frames a second. It's a huge amount of data. Most of the data never leaves the vehicle, right? Um, but there's a whole other type of data being generated. All a vehicle is made up of an enormous number, not an enormous number, but a decent number of ECUs, electronic control units,
Right.
and uh, and those things are always, the old vehicle architecture was known as CAN,
Mhm.
Common Area Network for a vehicle. It was developed, gosh, I think in the 70s. The little chart on the bottom right, or the little diagram on the bottom right, is what a CAN data frame looks like, which is so goofy looking. But the idea was that this car, you have these electronic control units, and they are emitting what is known as signals, CAN signals, on traditionally back in the say kind of traditional vehicles. So it'd be the actual physical layer was CAN. It's a bus-oriented network on the car, but Rivian and much like Tesla replaced that completely with gigabit Ethernet as
Yeah.
the backbone.
Yeah.
Uh, but the car itself, many of the control units, the smaller ones, not the Rivian designed internally a lot the principal ECUs of the car. Think of them as like functional areas of the car that are as compute dense as a uh, Mac motherboard, something like that.
Mhm.
You know, um, but but there's a bunch of smaller microcontroller type ECUs like door controllers and HVAC system things, and tire pressure sensor monitoring, and all those things emit traditionally CAN signals, and for most part you don't change that, but and ultimately that CAN ends up on this gigabit Ethernet backbone, and ultimately portions of it make its way to the cloud. So my team is responsible for building the software on vehicle to decide what data was to be stored for eventual transmit to the cloud. And my team was responsible for building the cloud infrastructure to house that data, to
Mhm.
process and house that data.
Mhm.
Um, and setting the policies on the vehicle as to what data do we want and when, and you know so it's a really fascinating thing because the amount of data generated on the vehicle is just enormous. I mean, I could characterize it by in some fashion, but it's most of the data on the vehicle, 90% of the data on the vehicle, 99% of the data on the vehicle never leaves the vehicle. It just
Mhm.
runs around and gets utilized for um, you know, driving and operating the vehicle, and then it's kind of disposed of or just disappears. Some of that data, though, is selected and and placed in storage so that it can be transmitted to the cloud in a store and forward model. And why do we do it? Well, that's the whole point of maybe the beginnings of this journey of we call it big data because uh, it's just I mean there's a formal definition to big data, but it's a little bit about the idea that you just have enormous data sets, and so now you receive these data sets, the ones that you think are interesting, and the challenge is always you know it's expensive to send the data. It's expensive to process the data. It's expensive to store the data, and so you don't always know. You don't have all the use cases. So in the beginning of the vehicle program, you store as much data as possible. Um, and when you have 50 prototype vehicles, in the entire fleet, that's easy. But when you grow it to a couple hundred, now you've got to start making decisions. And and then how does this relate to AI? Well, it's the beginning of it. It's the idea that by taking this data off the vehicle, bringing it to the cloud, storing it, and important to understand, running it through a particular pipeline that processes the data in a particular way that makes it uh, usable for various teams to then do different types of operations. And so teams like reliability, built their own AI stacks to ingest the data and try to get it to the level where you might almost interact with the, the representation of the data that vehicle saying, in common language, um, this vehicle won't travel over 60 miles an hour. What's wrong with it? that's kind of, or this vehicle has extreme wear on the left front tire. Why?
Hmm. Hmm.
Or this vehicle, unlike other vehicles, comes out of alignment more often, or, right?
Hmm. Hmm.
So, it's this is where my journey in data started. This, got serious. And when I started at Rivian, this was not part of my job description at all. We did not have a data team. We didn't have a cloud infrastructure. The cloud element started coming in place largely because we needed the mobile app to interface to the car when at distance, not. Um, but then it was very, very clear, I mean, to many people in the organization that data would be incredibly valuable.
Right.
And so I talked a little bit about that I probably talked at least as much about it here, but talk a little bit about what the tee up was and like how I got interested. I mean, it was super interesting to me. Like founding the cloud team was just like, I couldn't sleep at night thinking about all the awesome things we could do with data
Mm.
in the vehicle. It was really, really extraordinary. In fact, it was frustrating too because there were so many other activities. Eventually, I peeled myself away from those activities and just focused on data
Mm.
because it was just so interesting. Such a great, great problem to just the insights that you can develop about almost anything. And um, there's a there's an article I also wrote recently about FSD data, specifically FSD data, that's in my on my X account that I encourage folks to read because I talk about like not only do you have this box of data that can be applied to FSD itself, the idea of driving the car, but then you have use cases to manage, say, robotaxi, and then you have use cases of that data that far beyond. And every single application is AI driven. There's nothing there anymore that there's no. I mean, people could do straight analytics, but the problem is when you have one of the problems that like lots of data cause the problem, which is how do you sort through and find correlation and like on this vehicle here, if you were to say something like, why does the left tire wear right left front tire wear greater than the other tires, um, or some other arbitrary question. Uh, Trying to find the piece of data or the correlative pieces of data is like a needle in a haystack, and so it's only through AI that a lot of this awesome stuff is possible because well, we know why. I mean, we understand that AI allows to create this incredible dimensionality of relationship in the data, um, where just you know having having that data in a box, that box is so enormous that it's hard to dig through it.
Yeah. Yeah.
So that's how I got interested in this. That's why I really wanted to write the chapter because to kind of know a bit about it.
Yeah, a bit.
Yeah,
Yeah, and every chapter in the book, the authors chose the chapters they wanted to write based on
correct.
their own areas of expertise.
Yeah,
And we're not talking about low, it's like your level of expertise is right up there. I mean, Larry Goldberg, he's written the book on the decision tree, so he knows so much about the decision tree. I mean, when I say the book, I mean it's the book in the industry that like established the idea of computer driven decision tree. So, and it just goes like that, chapter by chapter. The people that wrote the chapters have a tremendous amount of professional background and experience in the categories that they're discussing.
yeah. Well, I mean, it's I think it's true. We was very privileged to be able to do this at this company. I mean, what a great thing. I didn't um it wasn't a job. It was, it was like
Yeah.
it was the thing I like I said, I had a hard time sleeping at night. I really wanted to get back to work and do something big every day. It was almost there was too much stuff to do,
Yeah.
really.
Yeah.
With
So
so
no,
many
yeah.
I mean, it got so intense that I wanted to actually separate myself from the actual day-to-day uh, aspects of managing the data, which then
Uh-huh.
became, it's not that it became boring in a sense, but it's like, okay, that's just the table stakes stuff to get to the next level.
Yeah, yeah.
So then at Rivian, I founded this futures team where we really went to the next level to try to learn how to use this data in applications that, frankly, a lot of them were beyond vehicle.
Yeah, so let's talk about that for a minute because I think it's one of the most fascinating parts of what's going on right now. And I'm guessing that I might even be a tad behind. We the whole time we're writing the book, we're like, we got to get this book out quickly
Yeah,
because it's changing every day. So I read, I'm not an expert in data, I'm not an expert in the details, the technical details of these things, but there was a lot made a few weeks ago about the fact that there's only so many words. We're running out of word data. Now sites like YouTube and X are providing new words every day, but ultimately the compute is going to be so big that this data is not going to be enough. And so this particular article was talking about that real world data,
right.
like Rivian, like Tesla provides, that will be the next layer of data. In other words, it's way more complex than the word data, and that we'll want to move into this real world data, not even necessarily to run cars or to run robots, but just because we'll need that in order to give the dimensionality and the density that we need to get to AGI. Do I get that sort of right?
Yeah, I would say this. Let me go back to here and talk about there's a section here on data compression,
Mm,
AI and data compression. And there's other topics that treat this, but here's what I wanted to say about that in regard to AGI. And so right now, what we've done with these LLMs is we've trained them on the written word of humans. Um, as I describe here, that's data compression. We've taken a bunch of thoughts that we have in our brains. I mean, consider this chapter. It's, I don't know how many words. Let's say it's 4,000, 5,000 words. Um, but I had 20,000 words I could have written.
right, easy.
So I compressed my thoughts
Yeah,
into to what I thought was the most important stuff, and I explained it, and hopefully I explained it correctly, and hopefully it is correct. And if the LM were to train on this data, it would create a idea of what the use of data is in AI from this chapter. But there's a problem, and the problem is that it's filtered or compressed through the human mind. So if you really want to build an artificial general intelligence that's superhuman or beyond human, you can't train on human output. You have to train your systems on the raw data.
yeah.
It's like go first principles. So the idea is that, if you think about a vehicle uh, taking in, say, uh, video data
Mhm.
and processing that data, um, it's it too is compressing it.
Mhm.
It's making decisions about what data eventually arrives in the cloud because there's too much of it. But it's not. And by the way, there's human decisions involved in the selection of that data. Tesla decides what data to select. But if you were to train on all of that data, you would see a world that's vastly different than how humans have described the world.
Okay.
And then just move that beyond FSD to Optimus, a bot that can walk around in places that a car can't go and observe the world, in similar ways to the way, say, Tesla vehicles are doing it today. Just imagine the amount of data that can be accumulated and how much we haven't talked about in the written word.
Mhm. Mhm.
So 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 real world data is incredibly important to build up, I would say, truth-based intelligence. And even more important if we want to go beyond human intelligence, because if we're just training on the outputs of the human brain, we essentially are at best um, matching it.
Yeah. Yeah.
Yeah.
Yeah. I
Yeah.
mean,
So
I suppose that the ability of the machine to quickly do analogies between fields or even within a field, but outside of fields. I mean, I know that I was working on, again, famously, I had the water bottle company and we needed to have the cap and we wanted the cap to be able to do different flows because some people like to get a lot of water when they squeeze their water bottle, and some people want to get a little bit of water when they squeeze their water bottle. And we wanted that flow to be changeable. Well, so by analogy, I look at showers, I look at other kinds of bottles that dispense liquids. So the other bottles would be within the discipline, the showers would be outside the discipline,
mhm.
and then your AI has the ability to very rapidly look at virtually everything that might have any application as long as you prompt it right and come back with analogies. And then you, as the human, get the opportunity to decide if any of those analogies are appropriate.
Yeah, there's there's a real world data is really the next frontier, I think. I think in a sense, I think you and I have talked about this, that Tesla, because of its scale, today 8 million cars, I would say maybe 5 to 6 million data sensors operable on today's roadways. But remember, they're not just observing what's on the roads, they're observing everything about a city.
Yeah.
And with great density in a city, they literally can understand the city in ways that we have never even come close to. Um, all these decisions, many decisions that we make as humans are very low data decisions.
Yeah.
And we're using our own special inference to intuition to make those decisions. But we often would love to have more data at our disposal. Um, and real world data, provides that. But then it provides the problem is how do you put a lasso around it? How do you wrestle it to the ground? How do you find correlation? How do you find anything within that haystack? Um, and that, having come through that at Rivian and seeing it firsthand, mind you, that of course, like I said, a vehicle like a Rivian or a Tesla as an IoT device is a very, very data intensive,
Yeah.
data prolific device. But regardless, it's still an extreme problem.
Yeah. And then you talked a lot about the data in, but then the data out becomes, oh, that tire is wearing in this way. Now we've got data about the way the car is operating that we can now take that data and ask the LLM or
Mhm.
the model. We can ask it, what are you seeing about this particular car? Because we're not finding this on any other car. It's only on this car. What looks like it might be the cause of this? It pops back with a list, maybe even. Well, here's the top 10 possibilities, or here's the most likely.
Yeah,
And then again, we point out in the book over and over again, that's where the human comes back into play. The human looks at the output and says, oh, okay, let me go check these three.
yeah, it's a tool. It's a
Yeah.
tool. It's a highly sophisticated tool, but it's a tool. And the number of use cases at which that tool can be applied for just manufacturing reliability, service, and sales. I mean, you need to know exactly how your vehicles are used with great, extreme amount of data about the actual use of the vehicle. Exactly how many are taken, how many meet your brand head on, how many are actually taken off road, what kind of dynamics do they experience, what your occupancy level looks like, where we we built these insanely beautiful and informative histogram type maps of the vehicles. In the case of just in the United States, the principal market for Rivian, and we would snapshot these. We would produce them once a day, but we could see the density of where we were, and we can match that to the potential projections of sales. And
Oh,
uh,
yeah.
yeah, we actually built an AI that um, computed where Rivian stores and charging components should be
Ah, yes, of course. Yes.
based on anticipated sales in an area.
Yeah, yeah,
Yeah.
yeah. Yeah, no, so of course that's my specialization, of course, is on the marketing side. And I've thought about that so many times,
Yeah.
how cleverly now, I've written books on retail, and making the decision where to place your retail store. If I'm one guy, I just have my one little shop. I've got until AI, I had limited information, and I would
Right.
recommend in my books, oh, go to your local chamber of commerce. They can help you take a look at that. Ask the industrial commercial real estate guy, and he probably can give you some ideas about traffic flows and whatnot.
Hmm.
But that individual's super limited. Now, McDonald's, they can go out and get real world data
Right.
um, over and above the data that's
Right.
available to the public. And they're going to, believe me, they're going to
Yeah.
know it
Yeah.
backwards, forward, inside out. But now, today, this is one of the crazy parts. Today, I can ask the LLM, and the LLM is going to have probably more data than that chamber, and potentially more data than I might be able to even more data than I might be able to even get if I posted people out on the street counting cars.
Yeah. And what's important is that it's the AI itself that can come to reasonable conclusions so that, you don't have to ask the intelligent questions. You can ask questions as simply as where should I place the next store?
Right.
And then it says, well, let's place it here. And then you say, well, why did you decide that? And then it comes up with, well, there are 5 reasons that I came up with. And then you could say, well, subtract this reason. Would you still place the store there?
Uh-huh.
You know. Um, let's jump into another
Sure.
fun one, synthetic data. Um, I took this picture here from a recent presentation, an article from Ashok Ellaswamy, who's the VP of AI at
Mhm.
Tesla. What you're seeing are the 8 cameras surrounding the vehicle recording uh, a roadway, except one thing. None of that is real.
Right.
That is all generated synthetically within the data center
Yeah. Yeah.
in real time.
Yeah.
Um, if folks have a chance to go look up his article, and he has a video of this very thing. This is a snapshot of a video.
Right. Right.
Um, and what they're able to do is extraordinary. They start with a template that might be exactly a real world snapshot of this particular, let's call it intersection, for lack of better definition. And from that snapshot, they can remove all the dynamic objects, the current vehicles and pedestrians that are in the scene, because they've identified that through their AI, right?
Mhm. Mhm.
I mean, that's what FSD does 36 times a second on your
Right.
vehicle.
Right. Right.
Yeah. And then they can place other types of objects that they wish, and they can create trajectories out of those objects that are um, consistent with how people drive, and then extraordinarily inconsistent.
Right.
Erratic behavior from pedestrians or animals darting across, and they could do it in such a random fashion that there would be no way to find this data in the real world.
Yeah. Yeah.
But the thing that's special about this is it doesn't start with zero. It starts with selection of data templates from real world vehicles. And those data templates, and what this is probably used for in this particular case, there's different uses for this type of thing. One of the things it's used for is just validation. So they can create their model, like FSD version 14.1.4, and then they can run vehicles virtually in the cloud through hundreds and thousands of different types of scenarios like this.
Right.
And they can build a performance score. In fact, I guarantee they're doing exactly that.
Yeah.
So before we ever see a release, that release has driven potentially millions and millions of miles in the virtual sense on simulators to validate and find, did it solve for the new things that release is attempting to solve for, and did it create regressions? Did it roll back, to any kind of bugs pop up that were in previous releases? This is extraordinary. The other real use for this is reinforcement learning. And what they do in that particular case is they not only generate a particular type of trajectory. See the white truck here? It has a particular trajectory. It's in front of the vehicle. In front of the vehicle is referred to as the ego, meaning self. Like that's the one that's generative in the sense. And so that vehicle has a trajectory, and they can set that up, and they can set up scoring, and then attempt to, if you can dig into, folks can dig into the topic of reinforcement learning if they want to know more. But the last article on FSD that I have treats reinforcement learning fairly well, and apply these rewards or penalties to certain behaviors, and they can set up thousands and thousands of what they call trajectories. I mean, that's actually the technical term in it, but in the vehicle sense, it makes a lot of sense. Vehicles, that particular white truck there can do thousands of different types of trajectories, and we can see how it affects. I mean, what I mean by trajectories, for example, is let's say that they're trying to determine how to decelerate the ego, the vehicle in scene here, relative to that white vehicle stopping. And how about relative to it stopping short? So if it stops short, there's a lot of different decisions that the ego can make. One is hit it.
Yeah.
I mean, you can actually make a decision that you want to do that, and there would be a penalty associated with hitting the vehicle. But there'd also be penalties for going into opposing traffic, and maybe the penalties into opposing traffic would be much higher because the relative speeds would produce more. The cumulative speeds would produce more damage and potentially more human damage.
Right.
So there might be less of a penalty to rear-ending the car in front of you than hitting, say, I don't know what it is, the BMW or something in the left oncoming. But there might be a better path. And so by eventually applying that, all virtually, all done in the cloud through this scenario, they were able to train. They're able to train beyond what the human sample set could ever deliver them natively. Right.
Yep.
So while this isn't real world data, it is sort of derivative data from real world scene. Yeah. And comes originally from the vehicles. So this is a big deal.
Yeah. I like it.
Yeah. Here's another section I wrote called Data Builds Function. I should say builds. I just wanted to kind of step back a little bit, and in this particular case, what I'm trying to say in this particular section is when we train an LLM, or we train any of these neural networks, whether it's for FSD or it's generative AI, we're essentially creating a function. So in the case of driving, we call it the driving function.
Mhm.
You know, if you look at the bottom, so the top is sort of this generic concept of a function, just like you would see one in math, like this, the
Sure.
function to sum two numbers. What's the input? The two numbers. What's the output? The sum of the two numbers,
Mhm.
right? What would that look like in code? Well, the function would be written in a language like Python or C or C++ or Java to called the add function, and it would input two numbers and add them and create an output or do something more complicated. Well, how do you build that kind of function in driving? Well, you do it by virtue of building a neural network. And what does that mean? Well, the data becomes a predictor of the future, you know, past data
Mhm.
becomes an incredible predictor for future outcome. Um, and so essentially, in the case of driving, uh, what FSD is effectively a driving function. Now, that function, if you kind of look inside, looks like this. It's a big, crazy neural network
Mhm.
with
Mhm.
all these different values for every string, you know, every connection point between. And by the way, this is small compared to there's a couple billion parameters in the FSD.
Right.
So, um, but that builds this function. And what's the input? The input is the camera data. Obviously, there's some other data, kinematic data, et cetera. Ashok describes this in his presentation as we are inputting for FSD 36 times a second on vehicle. We are inputting 2 billion tokens and we're outputting two.
Yeah, right.
2 billion, two. Now, to say what that means, 2 billion, 90 something percent of that is camera data. The next big bulk of data is 48 hertz microphone recorded data.
Mhm.
And then mixed in there is navigation routing type of data,
Mhm.
kinematics, vehicle kinematics, like the vehicle's IMU data, like roll, pitch, yaw, acceleration, um, potentially GPS position. Um, and that's the input data that quantifies those 2 billion input tokens. And the two, well, he combines, I call it three, but essentially what he says is we have steering angle and we have acceleration. Positive acceleration means where the control is to press this accelerator. Negative acceleration means the control is to use the brake or regeneratively use brake, depending on you know
Right.
what they need to do. Um, 2 billion to two, and what's the middle? A big function.
Yeah.
And what's incredible about it is 2 billion data values go in, two data values go out, and the function itself is data.
Yeah.
So data is pretty important.
Yep. Yeah. Pretty important.
Yeah. I mean, it's fascinating to think about that the function is a big box of numbers
Yeah.
that ultimately could be called a piece of data.
Yeah. Itself is a piece of data. Yes.
Itself is a piece of data.
And,
Yeah.
and all of it is becoming more and more valuable, which is why they call data the new oil, is that you can sell. I mean, we just had the New York Times sell, when I say just, I think it was, 6, 7 months ago, they sold their their archives as data
Yeah.
uh, to be used to make these LLMs better.
Sure.
And
Sure.
then you have people that have very specific data, maybe about medicine, that becomes a valuable set of data. Now, in the case of cars, you might have the real world data itself, the raw data, as you're pointing out, which is one set of data that would be valuable to other people who are working on AGI and need to take it to the next level. They just need data. They need, something to stimulate um, more opportunities for the thing to learn. But you also have that middle part, the functional data, which has been processed, manipulated, analyzed, whatever, that
Yeah.
it's its own
Yeah.
data.
So
Yeah,
yeah, in the case of like an LLM, that function is essentially a high dimensional uh, relationship of all language trained
right,
in the model,
right,
you know, and effectively you could also think of it as a compression of human knowledge.
right.
So you take all this word, all this stuff written, and you compress it into this thing. And this may sound a little bit like I'm underselling it, but it's the best word predictor. That's what it is. It's a
Yep.
word
Yep.
predictor.
Yep.
Um, and it's pretty good at it.
Hmm.
It can write things that are human level or better.
Or better. Yeah.
Yeah. Um, and it can, the fascinating part is I've written before about this topic is, and it's in this chapter as well. I think it's the last component here. I talk about from data to superintelligence.
Hmm.
And one of the things I'm talking about is data intelligence, or is there
Hmm.
that something about the intuitive uh, process of looking at that data that's intelligence
And
or so. But the reason that I say that is if you found a human that has a photographic memory, and there are those that are out there, you would say that they are very intelligent.
hmm. Hmm.
Um, and at that basis alone, now clearly people that express that kind of or have that type of capability really have a much deeper multi-dimensional intelligence. It's clear, it's obvious, right? There's very few people that just are, other than the type of Rain Man situations where you have people that are
Right.
good at doing math or doing. There's more to it than that, and we don't know what all that other stuff is. But if you treat it in a simple way without getting too fancy, in terms of photographic memory, having a great, I mean, if you could have any fact in your brain at any moment, most people would view you as pretty intelligent.
Right.
Um, so clearly, data is an ingredient.
Right. Oh yeah. And again, we spend what most of our lives, probably the number one thing we're doing is ingesting data, whether we want to or not.
Yeah, I mean,
It's automatic. It's like, you look out of your eyeballs and you're ingesting data. There's nothing you're going to do to stop that except, blind yourself, I suppose.
yeah.
So, okay, so we've got a chapter on data,
So
and
that's it.
that's it. Okay, yeah, yeah.
So
Now you don't have to read it. No, I'm kidding. You do have to read it,
yeah,
and you have to read the whole book. And so we want to encourage everybody to get their copy. Now, the as we're publishing this probably on Saturday, the audiobook probably is not out yet, but it should be out by the middle of next week. It's just a matter of the Audible people approving the content that we sent to them. Speaking of data, I'll let people know right now that the Audible voice is my voice, but it's cloned, and then the combination of all this data allows it to spit out my
yeah,
voice reading the content of the book, and it's remarkably good. I mean, yes,
it is.
could I have read it better? Of course I could, but it's very, very good.
Yeah, yeah. No, it is good. And in fact, I think where I find it to be very good at is just pronunciation of particular words that you go back a few years and the AIs involved in that would not get that right.
Yeah.
They would
Now
not get that right.
there is a producer involved, and the
Yeah,
producer does come in and sometimes you have to do something phonetically to,
yeah,
do a
yeah.
phonetic
Sure.
editing. But still, it's absolutely remarkable, and of course, way less expensive. Yeah. So than having either me or some reader, all my other books I've had Audible versions, but I paid a reader and a reader and a producer to actually put out the content.
Sure.
So anyway, that's all out there. It's already available in the print. It's already available in Kindle. You can get that right now, but the Audible will be sometime later next week. Any parting words of wisdom about data today?
I would love to have folks read the chapter and comment on it. One of the things, Randy, that when I was thinking about writing this, I'm not a big fan of using AI to write any material for me, but I was able to use AI in particular ways that, I mean, certain things like check this for grammatical accuracy, check this for spelling mistakes or other types of errors. Like tell me where I might be factually wrong. That's pretty that's a deep dive. You know, but one of the things that I thought was good was I said, okay, here's a chapter on data, related to AI, teed it up. What's missing? And
Yeah.
it did a pretty good job. It came up with about 15 things that
Wow.
I could have. I mean, some of it is really,
Yeah.
you're like, no, that's I missed that on purpose. That's a silly thing to put in there. But there are things that, I know that I am not interested in, therefore I didn't write about initially. And then I felt, okay, I better say something about
Mhm.
geopolitical aspects of data. I better say something about the competitive nature of data. Um, and so, I wrote those sections as well. Um, but they weren't there. They
Yeah.
weren't there. So it helped me with omissions, like things that were missing.
I
And I
think.
think, to be honest with you, if I probably when I got the entire manuscript or the entire PDF of the book,
Mhm.
I was able to ask it questions like, where are we talking duplicatively about data within the book? Where are we talking in conflict
Mm.
about topics related to what I wrote?
Right, right, right.
So, and by the way, I think that that's something that I think philosophically, and I think you treat that, and is that we purposely went out there and let folks write to their topic, and knowing that there would be overlaps
Yeah.
and some conflicts, because that's actually very good. That's a good thing, and
Right.
we did that on purpose. Of course, it's easier too. We didn't have to coordinate some massive effort of who did it, who how you defined your box, which I think
And, some,
is
and sometimes it was just the flow. I mean,
yeah,
sometimes, you're writing a chapter on energy. Well, in the chapter on energy, you're going to have to talk about, nuclear, let's say.
yeah.
Well, somebody else is writing a chapter on the overall stack. Well, when you're writing the chapter on the overall stack, maybe you have to talk about nuclear again in order to make the flow, or make it complete, or to
Yeah,
make
yeah.
it flow right. Yeah. So
Well,
yeah,
the
that's
thing,
what I would say.
that part where I say data, compute, and algorithm, if I treated it as if I was writing an entire book
Mhm.
on data, I would have gone extremely deep into, how do we compute this data? What exactly do we do with it? What are its, I probably, yeah, but I wanted to stay away from the topic of compute. I wanted to stay away from the topic of the neural network itself. Yeah, so
All right. Well,
fascinating.
yeah, as always, Phil, thank you for taking part of what is today? Today's Saturday? No, today's Friday. Taking part of your Friday morning to,
Today is
to,
Halloween.
yes, it is. It's Halloween. Yeah, I
Yeah.
don't know if this is my costume, but it's close. Anyway,
Mhm.
so for all of you out there, be sure to buy the book, and it's been great talking to you.